Hello, and welcome to Quantum Wonders, the podcast where we explore the unseen, the unpredictable, and the truly fascinating world of quantum science. I'm Quantum Secrets, and today we're diving into the mysteries of the quantum realm, a place where particles can be in two places at once, and where reality itself behaves in ways that defy common sense. So, grab your curiosity, because this episode will change the way you look at the universe. What is quantum physics? Before we get into the weird stuff, let's start with the basics. Quantum physics is the branch of science that studies the behavior of the tiniest things in the universe: electrons, photons, and other subatomic particles. Unlike the physics that governs our everyday world called classical physics, quantum physics plays by a completely different set of rules. In the quantum world, particles can behave like waves, and waves can behave like particles. Particles can be in multiple states at once, a concept known as superposition, and they can even be linked together across space in a phenomenon called entanglement. Sounds strange? That's because it is. But it's also real, and it's the foundation of modern technologies like lasers, MRI machines, and even the device you're listening to this podcast on, the double-slit experiment. One of the best ways to understand quantum weirdness is through a famous experiment called the double-slit experiment. Here's how it works. Imagine you have a wall with two narrow slits and a screen behind it. If you shoot tiny particles, like electrons, through the slits, you might expect them to go through one slit or the other and create two lines on the screen, right? But that's not what happens. When no one is watching, the electrons act like waves. They interfere with themselves and create a pattern of many lines, just like water waves. But the moment you try to observe which slit the electron goes through, just watch it. It suddenly acts like a regular particle and only makes two lines. This suggests that observation affects reality. It's as if the universe decides how to behave based on whether it's being watched. That's mind-blowing. Superposition, being in two places at once. Let's talk more about superposition. Superposition means that a quantum particle, like an electron, can exist in multiple states at the same time. It's not that we don't know where it literally is in all possible places or states until we measure it. Think of it like flipping a coin. In the classical world, it's either heads or tails, but in the quantum world, it's both until yay. This idea became famous with a thought experiment known as Schrödinger's cat. Imagine a cat in a box with a radioactive atom, a Geiger counter, and some poison. If the atom decays, the poison is released, and the cat dies. If it doesn't decay, the cat lives. Quantum theory says, until you open the box, the cat is both alive and dead, a superposition of both states. It's a metaphor, of course, but it shows how strange and counterintuitive the quantum world is. Entanglement, spooky action at a distance. Now let's get even weirder. Quantum entanglement is when two particles become connected in such a way that the state of one instantly affects the state of the other, no matter how far apart they are, even across galaxies. Einstein famously called it spooky action at a distance because it seemed to break the rule that nothing can travel faster than light. But experiments have confirmed it's real. Entanglement is at the heart of developing quantum communication, quantum encryption, and eventually quantum teleportation. Yes, teleportation. We're still in the early stages, but the potential is enormous. Real-world quantum tech. Quantum physics isn't just a playground for weird ideas. It powers real-world technologies. Let's look at a few examples. Semiconductors. The foundation of modern electronics, from smartphones to computers, relies on quantum principles. Lasers, used in everything from surgery to barcode scanners. Mr. I machines. These medical devices depend on quantum behavior of atomic nuclei. Quantum computing, instead of using bits like classical computers, which are either 0 or 1. Quantum computers use qubits, which can be in multiple states. This makes them incredibly powerful for certain types of problems. Google, IBM, and many startups around the world are racing to build the first fully functional quantum computer. Quantum computing, instead of using bits like classical computers, which are either 0 or 1. Quantum computers use qubits, which can be in multiple states. This makes them incredibly powerful for certain types of problems. Google, IBM, and many startups around the world are racing to build the first fully functional quantum computer. Quantum computing, instead of using bits like classical computers, which are either 0 or 1. Quantum computers use qubits, which can be in multiple states. This makes them incredibly powerful for certain types of problems. Google, IBM, and many startups around the world are racing to build the first fully functional quantum computer. Some interpretations of quantum mechanics suggest that every time a decision is made, the universe splits, creating parallel realities for every possible outcome. This is called the many worlds interpretation. It sounds like science fiction, but it's taken seriously by some physicists. Final thoughts. Quantum science is not easy. It challenges everything we think we know about the universe, but it's also beautiful, mind-expanding, and full of potential. From the tiniest particles to the biggest ideas about time, space, and reality. Quantum physics gives us a new way to look at the world and ourselves. So next time you hear a scientist talk about quantum entanglements, superposition, or teleportation, don't roll your eyes. The future might just depend on it. That's it for today's episode of Quantum Wonders. If you enjoyed this journey into the quantum world, don't forget to subscribe and share the podcast with your curious friends. Part 2. The power behind the paradox. And in this second episode of our quantum journey, we're diving even deeper into the strange and fascinating world of quantum paradoxes, interpretations, and the technologies of tomorrow. Last time, we explored superposition, entanglement, and the famous double-slit experiment. But today, we're going beyond the weirdness to ask, what does all of this really mean? And how are scientists using these bizarre quantum properties to build the future? Let's get into it. Quantum paradox is logic turned inside out. Quantum physics isn't just strange, it's paradoxical. It defies common logic. And that's exactly what makes it so powerful. One of the most famous paradoxes is called the quantum Zeno effect. Here's the idea. In quantum physics, the act of observation affects the system. So what happens if you constantly observe a particle? Well, it might just stop changing. Yes, watching something too closely in the quantum world might literally freeze it in place. It's named after Zeno, a Greek philosopher who imagined a paradox where an arrow in flight is motionless at every instant in time. In quantum terms, this freezing by observation has actually been tested with atoms, and it works. The more frequently you measure a quantum system, the more you prevent it from evolving. It's like reality won't move unless you look away. Quantum eraser. Changing the past. Let's get even crazier. In the quantum eraser experiment, scientists took the double-slit experiment to a whole new level. They showed that not only does observation affect reality, but erasing the observation after the fact can change the outcome. Imagine a photon goes through the double-slit setup. You mark down which slit it passed through. The interference pattern disappears. But then, after the photon hits the screen, you erase the which path information. And magically, the interference pattern comes back as if the particle never made up its mind about being a particle or a wave until you erased the evidence. In other words, the future action of erasing the data alters the past behavior of the particle. It's one of the strangest and most debated phenomena in physics today. The battle of interpretations. So, what's really going on here? Physicists don't actually agree. Quantum theory has multiple interpretations, and none of them are universally accepted. Here are a few of the most famous. Copenhagen interpretation. This is the classic one. It says the wave function collapses when you observe it. Reality doesn't exist in a definite state until it's measured. Many worlds interpretation. No collapse. Every possible outcome happens, but in a different universe. So, in one world, the cat lives. In another, it dies. You just happen to live in one branch. Pilot wave theory, Bohmian mechanics, suggests that particles have definite positions guided by a hidden pilot wave. It keeps realism but adds unseen variables. Quantum Bayesianism treats quantum mechanics like a tool for updating our beliefs, not a description of physical reality. It's more about what we know than what is. What does this mean for us? It means we're still trying to understand what reality really is. Even 100 years after quantum mechanics was born, the mystery is far from solved. Quantum biology, life goes quantum. Now, here's something most people don't expect. Quantum effects might not be limited to the world of atoms, and particles they may actually play a role in life itself. Here are two fascinating examples. Photosynthesis. Some research suggests that plants use quantum coherence to efficiently transfer energy during photosynthesis. It's as if the energy finds the most efficient path through the system, like a quantum GPS. Bird navigation. Certain birds may use quantum entanglement in their eyes to sense Earth's magnetic field, allowing them to migrate across continents with stunning accuracy. If these results hold up, it could mean that life evolved to take advantage of quantum mechanics, something no one expected just a few decades ago. Quantum technologies that could change everything. Let's switch gears and talk about the future. Right now, quantum science is powering a technological revolution. Some key areas. Qubits can hold multiple states at once, meaning quantum computers can solve certain problems millions of times faster than classical computers. They could break current encryption, model complex molecules, optimize global logistics, and simulate physics in ways we can't yet imagine. 2. Quantum communication. Using entanglement, we can build unhackable communication channels. China launched a quantum satellite, Michus, that proved encrypted messages can be sent using quantum key distribution. 3. Quantum sensors. From medicine to geology to national defense. Quantum sensors are emerging that can detect incredibly small changes in gravity, time, or electromagnetic fields. These could help detect earthquakes before they happen or even scan the human brain in real time. We're witnessing the early stages of a quantum industrial revolution. Should we be scared? With all this power and mystery, some people wonder, is quantum science dangerous? Like any technology, it depends how we use it. But here's something important to remember. Quantum mechanics doesn't just offer power, it offers perspective. It reminds us that we live in a universe far more complex and beautiful than we ever imagined, that we don't know everything, and that sometimes simply observing can change the outcome. It humbles us and inspires us. Final words. Embracing the unknown. We've traveled a long way in just 2 episodes, from the double-slit experiment to quantum teleportation, from paradoxes to quantum biology. And the deeper we go, the more we realize the universe isn't built like a machine. It's built like a mystery, one that reveals itself only to the curious. So keep asking questions. Keep wondering, because in the quantum world, even the impossible is possible if you're willing to look close enough. That's it for today's episode of Quantum Secrets. If you found your mind stretched, twisted, or inspired, then we've done our job. Make sure to subscribe for the next episode, where we'll explore quantum time travel and the nature of causality. Can you send a message to the past? You'll have to tune in to find out. Until then, stay curious and stay quantum.